Hi guys, it's Penguin Design here, bringing you part 4 on how to make a game like Crossy Roads. In this tutorial, we'll be creating the basics of the level generation, so this will generate between grass, road or water. Then in the next few tutorials, we're going to be adding logs, lily pads and cars as obstacles. So we're going to open up Unity and navigate to our Crossy Road project. So we're going to have to change a few things in Unity. The first is that under our main camera, we can change the background color. That was only there just for testing purposes. So I'm going to change it to a grey sort of white color. We're not going to see it, hopefully in the final game, but in this prototype sort of stage, we will see it. So now what we're going to do is go to Game Object, Create 3D Object and Cube. Set its position to 0 on each axis. Now here's the important thing. We're going to set its scale to 10 on the x-axis. And now what I'm going to do is in our materials folder, right click, create material, and I'm going to call this green. So now I'm going to drag this green material onto the player. So now whenever we adjust the properties of this, it will immediately affect that block. So as you can see, it's not being shaded correctly, and that's because it's using Unity 5 standard shader. But what we want is the legacy diffuse shader. Okay. So I'm going to select a green color, so right about there. Yep, so that's a nice green color. And so now I'm going to name this cube grass. Okay, so all its properties are pretty much done for now. Now I'm going to duplicate this object with Control D, and I'm going to name it road. And so as you probably guessed, we're going to create a new material, and we'll call this, let's say road. I'll set its shader to legacy diffuse and choose an appropriate color. Okay, now drag it onto this road object. We can't see it because it's inside of our grass object, but if we unchecked the viewing of our grass object, we would be able to see it. But in the Crossy Roads game, the road is slightly lower down than the grass. So you'll see what I mean in just a moment, but what I'm going to do is set its Y scale to 0.8. Okay, so actually these numbers are pretty important because they're going to be infected in code. So yeah, we're seeing glitching, but that's because you can't have two objects inside each other. But I'm going to leave them on top of each other. Now we're going to duplicate this grass material again and name this water. I'm going to create a material, and this will be called water. And I am going to choose standard legacy diffuse. Now choose a color that looks right. Yep. And drag it onto this water object. So if you can see, here's our water object, and here is our road object. So yep, that's looking good. And what I can do now is I can go into our prefabs folder, drag in water, drag in road, and drag in grass. So now we don't have any need for those, except for the grass one. So we're just going to leave the grass one where it is, just for now. And you're probably noticing that if you start the game, our chicken's going to be inside those objects. So before I continue designing the level, we're going to have to change the animation for the chicken. So I'm going to select the chicken object. In my animation window, under idle, I'm going to set its position to be 0.7, and up here 0.7, whoops, I meant 0.7, and back here 0.7. So if we hit play for that animation, it's still working fine, it's just above the block now. So now I'm going to select the jump animation and set it to be 0.7 here, 1.7 here, if we hit play, it's also above the block. So you can uncheck the record button, and now if we hit play, you'll see that our guy is now always above the blocks. So it's not a very good fix, but it will work for now. So again, we're going to be making the first little part of our level. So this part is not going to be randomly generated. What I'm going to do is, onto our level object, drag in the grass object. Now I'm going to hit Control D, set its z-axis to be -1, Control D, -2, Control D, -3, and now I'm going to keep going forwards. So I might speed this up just to make it a little faster for you guys. So I'm going to stop once I've reached an object that has a Z position of 11. So now I'm going to select all these grass objects and rename them to grass because I don't like the numbering. So if we hit play now, we have a little surface for our guy to run on, but what we want to happen is as he runs up, what should happen is that the levels keep getting generated. For example, this block might be water, this block might be road. So in order to do this, we're going to have to write some code. And so this is probably going to be the hardest code that we've written so far, but that's because in any game that is procedurally generated, such as Minecraft or Crossy Roads, the most complicated part is always the level generation. So we're going to just have to knuckle down and write it. And remember guys, this isn't even the complex level generation. So we'll get through it, but I'm warning you right now, this will be a bit of a grind. So I'm going to name this generation, or level gen, or whatever you want to call it. And in our level object, we're just going to drag in this generation script. So I'm going to double click on it to open it in MonoDevelop. And so now that it's open in MonoDevelop, once again, we're just going to delete these comments because the computer doesn't see them. And what we're going to do is define some variables. So first, we're going to need to define 3 game objects. So I'm going to set these as public so that we can drag them in the Unity editor. And I'm going to write game object with a capital G, and this one will be called water. I'm just going to delete this, sorry, not delete it. I'm going to select it, hit Control C, paste it 2 times, name this one road, oops, and name this one grass. So now if we hit save, go back to Unity, then under our level object, you'll see these 3 variables have appeared. So what we're going to do is in our prefabs folder, drag in grass under grass, drag in road under road, and finally drag in water under water. So now I can go back into MonoDevelop and do a little bit more coding. So we're going to define 2 integers. So these are numbers without a decimal. And by default, if you don't write anything before them, they're private. And these are going to be the random integers that we're going to be generating in order to generate our level. So throughout this, we're going to be learning a lot about random.range. So the first one I'm going to call first rand, okay, and the second one I'm going to call second rand. So I'm going to do one more int, and this will be the distance from player of where our levels are being generated. So I'm going to call this disPlayer, and I'm going to set this by default to be 12, because if you remember, we had 11 blocks in front of our player. Finally, we're going to generate a vector 3, so this is a position in 3D space, and this is going to be the position that our objects are created at. So I'm going to call it int pos, and that's because that's short for instantiate. So I'm going to just set this to begin with to be 0 on each axis. And now what we can do is just delete our void start because we're not going to be using it. And in our void update, we can start writing code. So all of this is going to be generated if the player, so input.getButton down, and they press the up key that we defined before in our bounce class, up, so it has to have the same name as that. So now inside these brackets, that's where we're going to be writing all our generation code. So you may be saying, well, that's a bit of a sketchy system because every time someone presses up, the player doesn't necessarily jump. Well, for me, that's not an issue. It's going to be a slight toll on performance, but it won't matter with Unity 5's occlusion culling. So now we're going to set the first random, which was called first rand, and we're going to set it to be random with capital R dot range. So this is you have the first number and the second number, and you might be saying, oh, why are you going between 1 and 4? Wouldn't that result in 4 results, and we only have 3 different block types? Well, random.range uses the first number, then all the numbers in between, but it doesn't use the last number. So yeah, it's a bit annoying, but you're going to have to learn it. So now we're going to create the if statement. If first rand is equal to 1, then do this. And I'm going to do the next if statements later though. So now I'm going to set the second int that we defined, which was called second rand, to be random.range, and you can put it between whatever you want, but I found that between 1 and 8 works. So don't worry, we're not going to be needing to create 8 if statements or 7 if statements. We're going to be using something called a for loop, which means it loops through depending on the conditions right here. So first, we're going to define an int, and we'll call this I, and set it equal to 0. It uses semicolon to say go to the next little part. And we say loop through this until I is less than our second rand. So if our second rand was 7, then this for loop would be called 7 times. So now I'm going to hit semicolon and I'm going to do I++. And so what this means is that I will increase by 1 every time. So now I'm going to set our instantiate position, which was called int pos, to be equal to a new position in 3D space. So that's new vector 3, sorry. And inside this vector 3, I'm going to set it to be 0 on the x, 0 on the y, and its z position will be distance. Oops, it was called displayer. Okay. So now once it's done this, we're going to set displayer to plus equal 1. So you could write displayer equals displayer plus 1, but in programming they've made it a bit easier, so all you have to write is plus equals 1. So that's just a nifty little trick. And now I'm going to set a new game object variable. So this is going to be private by default, and I'm going to call this grass instantiation, so grass ints. And I'm going to set this to be equal to instantiate, which means create an object. And now we've got to set the position of this instantiate. So now we've got to tell it what object to instantiate. So we're going to instantiate this grass object that we defined up here. So I'm going to write grass. And we're going to set as game object. You just have to write that after instantiating. Okay, but now it's instantiating at position 0, 0, 0. So we need to set its position. So we're going to write grass inst dot transform dot position equals instantiate position. So that was called int position. So int pos semicolon. So now what we're going to do is copy this if statement here all the way down, Control C, and paste it twice. So this one will be if randint is equal to 2, and this one will be if randint is equal to 3. So now what we could do, because this one's going to be road and this one's going to be water, if we wanted to, we could make road more common or less common. But for me, I'm going to leave it similar, and if we wanted to add in difficulties, for example, on easy mode, grass would be very common and the others would be rare, but on hard mode, grass would be rare and the others would be common. But for now, I'm just going to set it to be normal. So I can leave all of these as they are, but I'm going to set this variable to be known as road, and I'm going to instantiate the road object as game object. So now all I have to do is rename this variable here, and that's pretty much done for this if statement. And we're just going to repeat this process on the next if statement. So we're going to write water, and I'm going to instantiate the water object, and now I just need to rename the variable here, so water. So boom, if we save it, hopefully all of that should be working. Hit save with Control S, go back into Unity, it'll compile down here, and we don't have any errors, but just in case, I'm going to hit File, Save Scene, File, Save Project, and now hit play, and let's hope that this works. So let's go into our scene view and let's watch what happens. So, whoops, where has my mouse gone? Oh, there we go. So we're going to watch what happens in the scene view. So I'm going to press up, and it looks like it's generating it. That's pretty impressive. So let's see if we can get some water. Yep, we're getting water. But one thing I'm noticing is we got to change its instantiate position. So I'll explain how we're going to do that quickly. So onto our project, remember we changed the scale on the y-axis of these. Oh, and I just remembered that our water object, its scale on the y-axis should be 0.6, I believe. We can always change it. So now in MonoDevelop, what I'm going to do is for our road object, I'm going to set the y position over here to be negative 0.1, and I'm going to have to write f to tell the computer that it's a float. So this is going to be half the difference between 1 and the actual scale. So this will make sense. And for this one, which is our water, we're going to make it negative 0.2f. Save, go back into Unity. It will recompile. If we hit play now, hopefully that should be working. So yep, so as you can see, they have a difference in height, just like in the original game. So that's working really nicely. But, and as you'll notice, below us, it's always a straight line. So even when there's joins, it doesn't change the below position. So that's looking good. But now what we got to fix is, as you can see, if I double click on my parent object, he's floating above the road, and he works fine on the grass, and then on the water, it's even worse. So yeah, we're gonna have to fix this, but for now, it's actually working fine. I don't think the water will be an issue because we're gonna have lily pads. I'm just a bit worried about the road. So that's working well, and as you'll think, I was thinking to myself, well, what we should do is introduce a system where the objects behind them get deleted. But then I realized to myself, what if the player went backwards? So what I'm going to do is not add in any code to delete them when they're behind them. The only thing I'm going to do to make sure it's optimized is check occlusion culling under the camera. So this will mean it will only render the objects that are in our camera. It will only save a little bit of data for the other objects. So I can go to window and occlusion culling, and I can bake the data, but it doesn't really matter because it's being instantiated as our game runs. So really, I'd say that's the end of this tutorial on how to do the basic level generation. So Hope you guys had as much fun as I did. And don't forget to like and subscribe. Thank you for all your hard work.